Hey boys and girls, welcome back to Monroe Live. I'm here with Corey, and we're here with a couple of batteries. Over here we got the Tesla Model Y, and on the other side, Corey's side, we've got the Model S. And today what we're going to do is we're going to talk a little bit about the different battery pack, batteries, the configurations, just a little bit about the difference between these two battery packs because they are not similar. So what I'm going to do is I'm asking Corey to talk a little bit about what's going on with the Tesla Model S.
All right. So the first major difference is the cell that's chosen by Tesla. They're using the 18650 cell, which is slightly smaller than the 2170, which was used on the Model 3 and the Model Y. We've spent a lot of time going over the Model 3 and the Model Y packs and modules, but this is one of the 5 modules that's in the Model S Plaid. And what you'll notice is it's a slightly wider and a little bit lower profile, and this is actually cross-car. So when we tore down the Model 3 and the Model Y, as you can see over here, these are long and skinny, and there's 4 long and skinny modules in the Model 3 and the Model Y. There's 5 that are cross-car. And what's important about the configuration for the Model S Plaid is how many are in parallel and how many are in series. So as the cells are laid out in this module, you have 72 across and 22 in series. So this brick right here is 1,584 cells, 22S 72P. When you string 5 of these together in series, you end up with a 110S 72P, which is 7,920 cells. The Model Y and Model 3 for the 75 or 82 kilowatt hour pack has about half the cells, 4,416 cells. So when you buy a Plaid, particularly a Plaid, you're getting almost 8,000 cells and you have more in parallel. Now, Sam, do you want to give an example of the advantage to having more in parallel versus 46 in parallel here for the cells and 72 here?
So we've talked about this as like having strands in a rope, and quite frankly, what this does with having this much in parallel, what it does is it gives the energy is about the same, but the power out of the S is considerably more. Now, at the end of the day, people have already criticized Tesla for staying with the smaller batteries, the 1865s. But at the end of the day, you know what? It depends on what you want. So the Model S Plaid battery pack has more cells, and they have more in parallel, which that's going to give you the oomph you need to get off the line. That's why it's so quick. It's configured for speed. The other thing is, this came from the Fremont plant, and there's a reason for that as well. They already own it. Why would they not use those cells? So I want something fast, I want something efficient, I want something effective, but I also have to think of one other thing, and that's cooling. And this cools better, the S cools better than the Model Y. And the reason for that is a smaller diameter in the cells, and Corey's going to show you that right now.
So the cooling channels are very similar between the Model 3, Model Y, and the Model S, but these are small rectangular channels inside. But one thing that's different is they're only flowing in one half. They flow in one half and then down the other. So all of the cooling channels are on one side. On the Model Y and the Model 3, they flowed in the front and then out the back. And you can see we did a cross section right here of what the inlet and outlet look like, and I'm going to see if you can get it as close as you can. So it's going to flow in the top and out the bottom. What's important, one of the main things we've noticed is everything is executed in a very similar manner on this module and pack configuration, but slightly different. Nothing is identical. Even the cells are wrapped in this gray PET liner, and then there's a thermal glue which glues them to the actual cooling channel itself. Also, the foam in here is very, very rigid. So if you see all this blue foam, this is a very rigid. Actually, walk over here, you can see how hard this is. It's almost like a hard, rigid foam. The foam on the Model 3 and the Model Y is very soft. And Sandy, you can actually pick that off.
At the end, yeah, you can. I can pick this off with my fingernail. So, what's the reason or rationale behind it? Well, they need to wick away heat a lot faster over there, and because it's got more power. Power equals heat. And when you look at this, you can see that the PET goes pretty much, well, actually, it doesn't go pretty much around it. This thing is coated in PET, and then the other adhesives are added. Now, what does that do for you? Well, that means that I get a lot more wicking, and that's what this is called, is a wicking pattern. I get a lot more wicking of heat to get into my thermal extrusions. So these extrusions are called micro extrusions, and that wicking is going to make it so that I can pull the heat away from this cell faster. As I look at this right now, I see this as a way to make sure that the battery is going to be cooled. And so I've always said that, hey, you know, we should pull heat from down here. And the bottom of the battery, blah, blah, blah. Okay, that's fine. But if I'm going to do rocket ship starts and whatnot, well, maybe that's not the right thing. With engineering, there's always trade-offs. Do I want to do this? Do I want to do that? I mean, I could go to an LFP battery, right? I got the same amount of energy, but do I have the same amount of power? This thing is built for speed. That's the way it's going to work, and that's the way it is working.
Now, Sandy, now we're going to talk about how the modules themselves are fit into the pack. So we can see this diagram right here. You see 1, 2, 3, 4, 5 modules that are cross-car. I believe all these modules are exactly common. And then they have to be connected together. So when you think of a typical EV battery, if you take the lid off of a VW or any of the EVs in the past, you would see orange bus bars. They don't really have traditional bus bars. They're actually laser welding this, I want to call it like a jumper bus bar. So these little tiny squares were cut out with a razor blade by our team. So the weld was in these spots, and these wavy pieces of metal right here from this aluminum stamping allow for some thermal expansion and contraction between the individual modules. But the entirety of the current and amperage of the whole battery flows through just these center pieces, because the entirety of the current and amperage flows through each one of the modules, because all 5 are put in series. So if you look at the voltage of this, if you add them up, it's about 82 volts. You have 5 of them together, it makes roughly 400 volts. And once again, Sandy mentioned there's a lot more in parallel here. So one whole line is 72. Then the actual laser welding of the cells, each parallel set to the next parallel set, you can see these tiny little laser welds, and then there's these aluminum strips that go all the way across. And this is a row of positive, and the other right here is a row of negative, row of positive, row of negative. They are not all the same orientation, and this is a big difference between the Model 3 and the Model Y. On the Model 3 and the Model Y, over here, all of the cells are in one orientation. And you can see the top of the cell right here. I call it the top because you have the positive, and then the outside is the negative. The bottom of the can is also negative. So they're using a wire bond method on the Model 3 and the Model Y. We're not going to go into too much detail. We highlighted this extensively in our other videos. They're not using a wire bond here. They're essentially laser welding these long strips of aluminum to create that connection from the back, from the negatives of one cell to the positives of the other. Then on the other side, you have a different set of small pieces that are welded. And we have these nice diagrams that our team drew up, so thanks to the team for doing that for us. But you can see the difference between the side that we can see right here and then the bottom.
So one of the things that we can bring up here is that I've said in the past that we've never really worked for Tesla, but that's not 100% true, because when the S first came out, they had a lot of trouble with orientation and also with assembly of these modules on the Model S. This is like a long time ago when the S first came out. And so one of our guys, Tim Shaw, went down and helped them out with how to make it so that you could automate this different type of orientation. This is relatively simple, that not so simple. Again, why change if it works? I guess is the terminal, or the why change if it works. That's kind of what we could be thinking of when we're looking at the Model S, and quite frankly, it works. It works really well. It's got great cooling. So why not just keep it the way it is?
And although the cells are oriented in two different directions, this is a much simpler design than the early Model S's and X's. The early Model S's and X's had anywhere from 12 to 16 modules that were about a third this size. The center spine of the pack itself was structural, so you did not have full crosscar, and the collector plates were wildly, I mean, it wasn't random, but we saw one at the EV show. Very difficult, and they really struggled with the quality of the connections for the temperature and voltage monitoring. So now we're going to go to BMS. One of the things we really liked about the Model 3 and the Model Y was the elegance of the BMS. So this BMS sat right on the top of the module itself.
Right.
This is from the 3, and if you flip it over, you'll see there was 1, 2, 3, 4, 5 locations where they monitored temperature. When we tore down the Model Y, they reduced that to 2.
Yeah.
This Model S has 2, similar to the Model 3 and the Model Y, with the thermistor sensors being integrated in the board. You can see right here and right there. These are what interface with the end caps right here to pick up the temperature. And our team did a really good job of hypothesizing that you're going to want to pick up the temperature on the end of this channel, because you have the fluid flowing from one end in where it's coldest and one end out where it's hottest. Right here is where it's going to be changing direction. And you can see the end of one of the cooling channels right there. Then all of these right here on top, these 2 points are welded to these end collector plates. And then all of these points are for each one of the rows of parallel cells for monitoring your voltage. This is very low profile. It's not encased in anything. Many of the other OEMs that we'll tear down will have their BMS in a plastic housing with a traditional wiring harness going out of it.
So the one thing that I think is kind of interesting is the little the little Easter egg down below that I can't read, but
says Tesla Inc. made on Earth by humans.
Yeah. So just to differentiate there. So at the end of the day, looking at longitudinal batteries versus basically side to side, or the modules basically are running parallel to the seats. These things are all kind of design efficiencies that they wanted to have based on what they wanted the product to do. This goes really fast. The Model Y, Model 3 goes, but they can't touch an S. And a lot of the things have to do with, or all those things have to do with, how do you control the heat? How do you control the cooling? How do you control the electronics the electrics that are associated with it. How do we make all that stuff happen to get what we want? And that's where Tesla really succeeds over everybody else. I don't think people are really thinking about all of the stuff that goes on inside these battery packs, and that's probably why it's these guys that are leading the pack. I mean, I was very, very happy with the. I am very happy with the Rivian, but it's not a Model S. It's not a Model 3, and neither one of these is a Rivian. So I don't want to get into a situation where we start getting into big arguments about what's best or what's worst, but every one of these things has been engineered, not designed, engineered to do the job that they need to do.
So this jumper right here, which connects the each of the 5 modules together, there's this piece that's welded to the end, and you can see 1, 2, 3, all of these small little pieces. These are going to pick up the last row of cells. After they pick up the last row of cells, it's going to give you a wide area to then weld on this piece right here. And you can see how they're laid on top of each other. So this entire pack is essentially a complex array of very carefully engineered flat pieces of aluminum, all laser welded together. Now, Sandy, I think we counted up over 16,000 welds. How important is it to control the quality of your processes and your tools you use and your...
Right.
You want to go there?
So, yeah, so in the build of a car, one of the things you try and do all the time is get to 6 Sigma quality. 6 Sigma means that you're allowed 3 failures per million opportunities. However, when you start looking at welding and stuff like that, these laser welds and whatnot, the number is vastly different. You go to 7 Sigma, which is 1.3 failures per billion. That's kind of a different sort of a scenario, and that's what we're looking at here. We're guaranteeing that these guys are looking at a 7 or a 7 plus kind of Sigma rating in order to make sure that this works. So let's ask the question, what happens if one of these welds doesn't work, right? So that means I lose a cell. So how much would that cell be worth? And I think
slightly
it's worth
more than 1%.
Slightly more than 1%.
1/72.
Yeah. So that's it. So you're looking at, even if you screw up, you're not going to damage the effectivity of the rest of the battery pack if you screw up with one weld. But I don't think you are, because lasers, a laser welding operation, they almost never screw up. I've had machines that ran for years without having a single operational failure, not a weld failure. So, and by the way, there's another thing that happens. If the weld doesn't connect, your weld controller will tell you. It'll tell you that somehow something didn't go right, and you can stop the machine, and then, or you can just have the machine go back and give it another shot. There's a lot of changes that have happened in welding, especially laser welding over the years.
All right, Sandy, so that was a quick run through of the Model S Plaid battery module and pack, how it's assembled, some of the pieces and parts. We hope you learned something, but really the thanks goes to our experts. So we have Michael, Julian, and Antonio that have been working on this for the better part of, I don't know, 2 or 3 months. Yeah. So thanks to them. Yeah. They've really been kind of feeding us the information. Right. If you ever want to learn more, we create reports that we sell. Sandy and I, we rarely mention this, but we have clients all over the world that rely on our data to make decisions moving forward. So you want to...
Well, yeah, because I know who's buying and I know who's not buying. And those of you out there that are not buying, you're going to fall behind. And I think you're behind already. Well, I've already talked about who I think winners and losers are going to be. And I'm telling you what, it's time to pick up the pace. What we've just talked about briefly is enough to maybe get you excited or interested, it's a real good idea if you start looking at what do you need to do in order to stay in the market. Because trust me, the Chinese are coming, and they're not stupid. They do not build crap products. You need to really think hard about the reports if you happen to be in the OEM business.
Yeah.
So,
and we also have an announcement. I am headed to Florida this weekend, so I think this will be airing a few days after, to pick up a brand new Model Y built in Texas with the 4680 cells. So if you're watching this right now, it's most likely Wednesday, and the vehicle will be approaching our facility. We're going to immediately tear that down, get the battery pack out. There's much less cells. So when we're talking about 7,920 cells, 4,416 cells, we're thinking roughly 800 cells. We've heard 804 or 848. These cells and the configuration of this structural pack, this is one of the biggest game changers we've seen from a battery pack perspective in a long time. And the Chinese, like Sandy mentioned, are right on their heels. CATL just today announced they have a battery system that competes with the 4680 cell. They're saying 13% better from a volumetric perspective. I think volumetric or gravimetric, one of the two.
but at the end of the day, I can tell you what 13% better means: 13% less cost, and the 4680 is already bare minimum 30% cheaper, 30% lighter, and gives you the same amount of and gives you 30% more power.
And who did CATL use to compare against? They compared it to the 4680 cells.
Right.
So we are going to have the latest and greatest of technology. We're essentially taking a brand new Model Y and ripping that battery pack out. We're not even driving it.
No.
Barely at all.
So here's the deal. Those 4680 cells, as you know, we've spent an awful lot of money this year on product that we're hoping will sell. But this time, we're going to be selling the cells, the 4680 cells, out of that battery pack. There's only a few hundred. 800. We calculated 786 or something like that. We know we were wrong because our diameter was a little different and whatnot, but those cells are going on sale. But I don't know.
So we're going to sell them. They'll be available for pre-order. It may take us about anywhere from 3 weeks to a month and a half to get them out, get them encased, and get them shipped. But if you work for a battery supplier, you work for a Tier 1, a Tier 2, an OEM, it's going to be near impossible for you to get your hands on a 4680 cell unless you order from us. So that there'll be a link in the description. Those will be on monroelive.com, a place to buy. Yeah. And then if you're interested in reports, as always, you can email us at sales@leandesign.com.
So the other thing too is if you happen to be a battery supplier and whatnot, your cells can be picked up. They will not be in a case. For anybody that wants one sitting on their desk or something, those ones will be encased in plastic, in epoxy, so that you don't burn your house down or what have you. But at the end of the day, we should mention too that this car is coming from Texas. That means it's going to have the giga castings on either end and in the center. So we are going to tear out the battery pack. And by the way, for all those doubting Thomases who said it was full of shit, here's a little surprise. We're going to videotape as we move the battery pack out, and you're going to see that the seats are going to come out with it. I don't know why people doubt me. You shouldn't tell Sandy. Anyhow, we're going to be showing you that, but our big thing is let's find out what those castings look like. And by the way, that's the other thing. Corey and I are going to be going next week to IDRA to have a look at the presses that are going to be installed at the Gigafactory. And we're going to probably find out a little bit about what other company. We already know one. We know that Geely is buying those castings. They've already done their calculations. Actually, they did them a long time ago when I was still in China. And they know that those giga castings are going to be the right way to build business and cut down labor hours and cut down factory floor space and on and on. So we'll find out if there's any more people that are out there buying these new presses to come up with a new way of doing business. So those are going to come out, and then I also want to look at the motors, because we're under the impression, we haven't been told, but I know that the Chinese electric motors are using hairpin design, and I'm wondering if the Gigafactory, the new Model Ys, whether they're coming out the same way. So we're going to be doing powertrain first, and then find out whatever else is going on inside those cars second. So with that, anything else?
That's it.
Good. Hey, thanks for watching, boys and girls, and stay tuned. We're going to bring you stuff from Italy. After we come back from the Hydra program, you're going to see lots of good stuff coming down the pike with the rest of the Model S Plaid, and the Y, and we'll have a few other surprises. I don't want to give everything away. Okay, so long.